Section 7.1 is all about complex numbers. Now, we've talked about complex numbers before, but we've never really gotten to work with them. So, without further ado, the last section of the semester, complex numbers. So, first off, the imaginary unit I is defined as the square root of -1. Because of this, I squared is -1, right? Because squares undo square roots. So we call I the principal square root of -1. And I have that for any real number, b, the square root of -b equals I square root of b, right? We're kind of pulling out a factor of -1. So if I have the square root of -100, that becomes I square root of 100, right? Because I, remember, is the square root of -1, right? That would get us back to where we started, but that's not how we want to do things anymore. So I pull out a factor of I, and then I go ahead and simplify. I've got the square root of 100, which is 10, and I'm going to rewrite that as 10I. And the reason I'm going to rewrite it with the 10 in the front is typically we do like our constants in front of, previously we've worked with variables, right? But we want them in front of any letter. Next, if I have negative the square root of -36, that's -I square root of 36, which becomes -6I. The square root of -2 becomes I square root of 2. I can't really simplify that any further. And the square root of 54 becomes I square root of 54. Here's the thing, I can simplify 54. 54 factors into 2 and 27, which is 9 times 3, which is 3 times 3. So I've got 3 squared and 2/3 left over. So I have I square root of 3 squared times 2 times 3. That's going to give me 3I square root of 6. So we simplify radicals that are imaginary the exact same way. The thing is just first we have to pull out a factor of I. So when we're multiplying complex radicals, it could be really tempting, right? Remember when we multiply radicals, we multiply what's under the radical symbol. So the square root of A times the square root of B would be the square root of AB. But here we have to pull out the I first. So I'd have I square root of 4 times I square root of 9. That gives me 2I times 3I, which is 6I squared. Remember, I squared is -1. So that gives me 6 times -1, which is -6. Let's try that again. If I have the square root of -3 times the square root of -7, that's the square root of I square root of 3 times I square root of 7, which gives us I squared square root of 21, so negative square root of 21. If I have the square root of -2 times the square root of -8, that's going to give me I square root of 2 times I square root of 8. That gives me I squared square root of 16. So my answer is going to be -1 times 4, which is -4. Lastly, if I have the square root of -5 times the square root of 6, that gives me I square root of 5 times the square root of 6, which is I square root of 30. And I can't simplify 30 any further because it's 3 times 2 times 5. Remember, when we're dividing complex radicals, we still have to rationalize the denominator, right? I equals the square root of -1. So if I have I square root of 75 over I square root of 3, that's going to have to be multiplied by I square root of 3 over I square root of 3 because I is a radical. That gives me I squared square root of 3 squared, which is -1 times 3, so -3. And that gives me I squared, I probably should have simplified this 75 first. Friendly reminder that the square root of 75 is, because 75 is 3 times 5 times 5, it's 5 square root of 3. So now I have I 5 square root of 3 times I square root of 3. That gives me I squared 5 square root of 3 squared. So I have negative 1 times 5 times 3, which is negative 15. So I have negative 15 over negative 3. Well, that just becomes a positive 5. Well, that simplified quite nicely. Okay, if I have I square root of 32 over the square root of 8, remember the square root of 8 is 2 square root of 2 from when we were practicing simplifying radicals. So I'm going to multiply by square root of 2 on the top and the bottom, but I'm going to do that after I simplify the square root of 32. Remember the square root of 32 because 32 is 2 to the 5th. That gives me 4 square root of 2. So now I have 4i square root of 2 over 2 square root of 2. And I have to multiply by the square root of 2 on the top and on the bottom. That's going to give me 4i square root of 2 squared over 2 times the square root of 2 squared. Well, that gives me 8i over 4, which is just 2i. So if a and b are real numbers, then any number of the form a plus bi is a complex number. So a is the real part and b is the imaginary part, right? Complex numbers can have a real part and an imaginary part. They definitely don't have to have a real part, but sometimes they do. So when we're adding and subtracting complex numbers, what we want to do is we want to add the real parts and add the imaginary parts. So if I have 2 plus 3i plus 6 plus 4i, that gives me 2 plus 6, which is 8, 3i plus 4i, which is 7i. If I have 4 plus 2i plus 3 minus i plus a negative 6 plus 3i, that gives me 4 plus 3 minus 6, which is 1. And then I have 2i minus I, so I just have 1i plus 3i is 4i, right? It's basically like combining like terms, except now I isn't a variable, it stands for the square root of negative 1. If I have 6 plus 5i minus 3 plus 2i, I want to go ahead and distribute that negative just to make sure I don't forget to change the sign. So now I have 6 minus 3, which is a positive 3. 5i minus 2i is a positive 3i. So if I have, hi Bobby, 7 minus 3i minus 8 plus 6i, I have 7 minus 8, which is negative 1, negative 3i plus 6i. That gives me a positive 3i. So that's how we're going to add and subtract complex numbers. When it comes to multiplying and dividing complex numbers, don't forget that I squared equals negative 1. That's why I put this in all caps in the bottom. Also, when you're dividing by radical numbers, don't forget to rationalize the denominator, right? We don't like radicals in our denominator, and I is a radical. So let's start with multiplication. If I have 4i times 2 plus 3i, that gives me 8i plus 12i squared, which gives me 8i plus 12 times a negative 1. So I would have negative 12 plus 8i. Remember that we like to have our real part and then our imaginary part. For problem 2 here, I'm going to have to FOIL. So I'd get 12 minus 6i plus 20i minus 10i squared. I know I'm doing math. It's so exciting. So that's 12 plus 14i minus 10 times negative 1. That's going to become a positive 10. So 12 plus 14i plus 10. So I've got 22 plus 14i. Let's try that again. If I've got 2 plus 3i times 1 plus 5i, that gives me 2 minus 10i plus 3i minus 15, we aren't adding, minus 15i squared. That gives me 2 minus 7i minus 15 times negative 1. So that gives me 2 minus 7i plus 15. So my final answer is 17 minus 7i. I'm going to go ahead and clear some space, and then we'll do the dividing by complex number problems. So remember, when we are dividing complex numbers, we're dividing by a radical. So we need to rationalize our denominators. In order to do that, I multiply by the conjugate. So I have 5 minus 2i over 5 minus 2i. That makes my denominator 25 minus 10i plus 10i minus 4i squared. And my numerator, 40 minus 16i plus 45i minus 18i squared. So my denominator is going to end up being 25. Remember that I squared is negative 1, so it's going to be 25 plus 4 over 40, negative 16 plus 45 is positive 29i. Minus 18 times negative 1 is plus 18. So my final answer is 58 plus 29i over 29, which I can simplify. 59 divided by 28 is 2. 29i divided by I is I. So my final answer is 2i. For my last example of dividing complex numbers, I have to multiply by I in the numerator and the denominator. That gives me I plus I squared over I squared. So I squared is negative 1. I have negative 1 plus I divided by negative 1. That's going to give me a positive 1 minus I. So when we're dividing complex numbers, we're really just rationalizing the denominator. The last thing I want to talk about real quickly is working with I all by itself. So friendly reminder that I squared is negative 1. I equals the square root of negative 1. So if I have I cubed, that's I times I squared, which is I times negative 1, so that gives you negative I. And if I have I to the fourth, which is I squared times I squared, that's negative 1 times negative 1, which is 1. So if I had I to the 12th, I might want to try and rewrite that to the fourth power, right? That gives me I to the fourth cubed. Well, 1 cubed is 1. If I have I to the negative 2, that's 1 over I squared, which is 1 over negative 1, which is negative 1. If I have I to the negative 1, that's just going to be 1 over I.